In the previous video, we talked about sieve of Eratosthenes to find all the prime numbers between 1 to 100 very easily and a very convenient method, right? So let's use that to solve our next example. Write all the prime numbers less than 15. So from the sieve of Eratosthenes, we can directly say that we know 2, 3, 5, 7, 11 and 13 are the prime numbers less than 15, right? So if you haven't watched the video yet, you can go to the description and check that video out. Now before talking about or discussing about some of the facts related to the prime numbers, first of all let's discuss, or we can say let's revise what are even numbers and what are odd numbers, right? So we know that even numbers are the numbers which are divisible by 2, right? The numbers which are divisible by 2, right? And what are odd numbers? All the other numbers other than even numbers are called odd numbers, right? Or we can say which are not divisible by 2, right? Simple. So now let's take an example. Let's say 176532. Okay, so tell me whether it's an even number or it's an odd number. So in order to find out whether a number is even or odd, what the definition says is, if the number is divisible by 2, then the whole number is an even number, right? So for this big number, when if we are going to divide it by 2, it will take much time, right? So let's discuss one shortcut. So the easiest way of doing is, let's consider the ones place digit of that number, right? Ones place digit, if the ones place digit is 0, 2, 4, 6 or 8. So if the ones place digit is any of these numbers 0, 2, 4, 6 and 8, then the number is even. Okay, and if there is, let's say 1, 3, 5, 7, 9, right? If these are the ones place digits, then the number will be odd. Simple. So for this big number, we don't need to divide it by 2. We simply see that the ones place digit is 2. Then we can say it's an even number, right? Okay. Now let's discuss some of the very important facts about prime numbers. First is 2 is the smallest prime number which is even. The second is 2 is the only prime number which is even. We need to take care of this and we need to remember these two very important facts. These will help us in the future questions and problems. Let's start with exercise number 3.2. So the first question is, what is the sum of any two? First part is, what is the sum of any two odd numbers? Okay, let's take some examples. uh, let's take two odd numbers, let's say 3 and 5, and let's add them. 5 plus 3 is what? 8, and we all know 8 is a even number, right? Let's take one more example. Let's say we take 7 plus 11. Okay, 11 plus 17 is 7. 11 7 plus 11 is what? 18. 18 is also even number, right? So the sum of any two odd numbers is always even. Okay, so the next part is, what is the sum of any two even numbers? Now let's take two even numbers. Let's say we take 2 and 4, right? 2 and 4, 2 plus 4 is what? 6, and 6 is an even number, right? Let's take one more example. Let's say we do 20 plus 4, or let's say 20 plus 6. 20 plus 6 is what? 26, and so the unit place is 6, so which means it is also an even number. So from these examples we can say that the sum of any two even numbers is also always even. Okay. So the second question is, state whether the following statements are true or false. So we will be given with some statements and we need to identify whether the statements are true or false. Okay. So the first statement is A part. The sum of three odd numbers is even. So we will try to solve all this with the help of examples, right? So let's take any three odd numbers. Let's say we take 3, 5 and 7. Okay. Now what we have to do is we have to sum these values. Okay. So 3 plus 5 plus 7 is what? 15. Okay. So 15 is what? 15 is an even number or odd? Odd, right? 15 is odd. Okay. Let's try to verify this with one more example. Let's take, let's say 5 plus 1 plus 11. Right? 5 is an odd number, 1 is an odd number, 11 is an odd number. Okay. So 11 plus 1, 12, 12 plus 5, 17, which is again odd number. Okay. So the statement, the sum of three odd numbers is even. This is what? This is false. Right? So this statement is false. So let's come to B part. Sum of two odd numbers and one even number is even. Let's take two odd numbers. Let's say 1 and 3. Okay. So now two odd numbers and one even. Let's take the even number 2. Okay. Now sum these values. What it will be? 1 plus 3, 4. 4 plus 2, 6. And 6 is what? Even number. Okay. Let's take one more example. Let's take 3 odd number plus 5 odd number plus, let's say, even number that we take is 6. Okay. 3 plus 5, 8. 8 and 6, 14. Okay. Which is again even number. So what the statement is saying, sum of two odd numbers and one even number is even, which is true, right? So this statement is true. Okay. So the third part is product of three odd numbers is odd. Now let's take three odd numbers. Let's say we take 1, 3 and 5 again. Okay. Now this time we have to multiply them, right? 1 into 3 is 3. 3 into 5, 15. Okay. And 15 is what? 15 is an odd number. Okay. Let's take one more example. 5 plus 7 plus 9. Okay. 7 5s are 35, and when we do 35 multiplied by 9, it will come out to be 315. Okay. Right. So 315 is what? This is again odd number. Okay. So we can say the product of three odd numbers is odd is true. Okay. Now next part. If an even number is divisible by 2, the quotient is always odd. If an even number, let's take the even number 4. Okay. If this is divisible by 2, the quotient is always odd. So whatever we get here, let's divide 2 multiplied 2 is 4. Okay. Remainder is 0 and the quotient is 2. And 2 is what? An even number. Okay. Now can we say from this that the statement is false? No. Let's take one more example. Let's say we take the even number 6 and we divide it by 2. So it will be 2 3s are 6. Remainder 0. Okay. And 3 is what? 3 is an odd number. So when we are dividing the even numbers with 2, sometimes we are getting even number, sometimes we are getting odd number. So what the statement is saying is, if an even number is divisible by 2, the quotient is always odd, which is false. Okay.